Example 11 and the last one in this topic. A rod AB is 3 meters long and has a weight of 20 newtons. Note weight. So we are not going to affect weight with gravitational effect. It's already affected. A weight of 20 newtons. It is in a horizontal position, resting on supports at point C and D, where AC is equals to 1 meter. You can see AC 1 meter and AD 2.5 meters. From point A to point D is 2.5 meters. The magnitude of the reaction at C is 3 times the magnitude of the reaction at D. The magnitude of the reaction at C 3 times, so if this is R, then this is 3R. It's 3 times the magnitude of the reaction at D. Find the distance of the center of mass of the rod from A. The distance of the center of mass of the rod from A. Of course, this is an ununiform rod, and therefore we are expected to find this distance and call it x from A to the center of mass. The weight of the rod is 20 newtons. There it is. And there is 3 times reaction at C as there is at D. And of course, solving vertically, you will be able to see, because you have to balance. We have to have the balance, vertical balance. 3R plus R is equals to 20 newtons. And therefore, 4R being equals to 20, you can already see that R is equals to 5. The value of R is equals to 5. And therefore, at that point, if we take moments about A, and I told you it is not a must that we have a fulcrum so that you can be able to take moment around or about that point. We can take moment about any point. So for easy calculations, if we take moment about A, we are going to see that 20 multiplied by the distance x, 20 multiplied by the distance x, we are going to balance the moment anti-clockwise and the clockwise moment. So 20 newtons is obviously anti-clockwise, so 20x is equals to 3r times 1 is anti-clockwise, 3r, and of course you know what r is. That means, but r is 5, so 15 times 1, which is 15 times 1, plus there is 15 times this perpendicular distance 1 meter. The moment about A affected by this r, which is 5, is also anti-clockwise. You can see 3r anti-clockwise, so they both combine to suppress the moment about A affected by 20 newtons, which is clockwise. So we're talking about 5, because of this r is 5, multiplied by what distance? 1 plus 1.5 times 2.5. Well, 20x is equals to 15 plus 5 times 2.5 is 12.5. And of course, we are going to have 20x being equals to 27.5. If you divide both sides by 20, you'll find that x is going to be equals to 1.38. This is to 3 significant figures. 1.38 meters to 3 significant figures. So the center of mass is 1.38 meters from point A, because absolutely this is the value of x. And the reason why we had to take A as the point of rotation is to avoid further substitution if we happened to place x elsewhere. But now that our x is directly where we need it, then we can get our final value of x as 1.38, which is the answer we are expected to give. All right?